All right. Once again, welcome to the Prestonsburg campus of Big Sandy Technical Community College. This is in the summertime. And what you're going to see here is the second flipped video from AP Calculus. Now, in your textbook, this would be looking at the content for section 1.2. So in this PowerPoint here that I'm going to be describing for you, we're going to look at finding limits graphically and numerically. Now, we've already done the introductory video. Hopefully you watched that. So we're going to kind of go through this PowerPoint. I'm going to point out some stuff, describe some stuff. Now, first of all, to get started, make sure you have your graphing calculator with you. Make sure you have your notes ready. We're going to kind of go through. There's some problems that I'm going to work, and there's some I'm going to ask you to work first, just as a guided practice exercise. And then we'll see. I want to see if you get the same answer that I got. So make sure you get your calculator on and ready to go. Now, a little bit about this section here as we get started with this video. We're going to begin with a little introduction to limits. Okay, after that, we're going to look at estimating limits numerically, that is using a chart or a graph, right? And then after that, how to estimate a limit graphically. So what if you're given the graph of a function? How would you determine a limit at a particular value? So that's what we're going to be looking at here. So a little introduction, estimating a limit numerically, and then we're going to finish up with estimating a limit graphically. All right, so let's get started. Then also, last, I forgot to mention, we're going to look at kind of how to determine when a limit fails to exist. So when does it fail to exist? So let's get started. Now, in the 2005 AP Calculus course description, it says, this talks about limits. There's a couple things it says. First, it says that a student should be able to estimate limits from graphs or tables of data. That's what we're going to be doing here, right, in this PowerPoint. Have an intuitive understanding of the limiting process, right? And after that, how to calculate limits using algebra. So you got to have some more algebra skills when you're working with limits. So to start off here, part one, we're going to take a look at estimating limits from tables of data. So estimating limits from tables of data. So to get us started, let's take a look at our first function. So this is actually our first limit that we're doing. We'll do a bunch of them here before in this unit, how to as we estimate some limits or determine the limits of some functions. The first function here says we're going to find the limit as x approaches 1 of the quantity x cubed minus 1 divided by the quantity x minus 1. So let's start off. Now I'm going to do the first one. We're going to do a little chart. I'm going to show you how to do it. Now the next one I'll ask you to do first. So a little guided practice there. And then when we come into class, we'll do a bunch of these. All right, so to get started. So here's our function. Now, first thing I want you to do, you got your calculator there. Go hit y equals on your graph. If you have a graphing calculator, hit y equals. Put it in your function list. That way you don't have to keep retyping the function over and over again. You can just use the table on your calculator, or you can just use your calculator to quickly generate some of these function values. So to get started, so we're going to find the limit as x approaches 1. All right, now, first thing we want to do as we estimate our limit, typically we want to take the 1 and substitute it directly in for x. Now here's the problem. Substituting 1 in for x gives you 1 cubed minus 1 over 1 minus 1. And you get 0 over 0. Now division by 0 is not defined. So this particular function, 1 is not in the domain. So that indicates two things. When you have a fraction like this, either you have a vertical asymptote or you have a hole. Now in this particular function, we have a hole. But we can still determine the limit as x approaches 1. But here's the problem. We can't use 1. I said if we could, we just take the 1, plug it in for x, but when you do, you get 0 over 0. That's a hole. So now let's take a look at the graph. Now you got your calculator, so you can generate a real pretty graph. I kind of did a little estimated graph just on PowerPoint, so mine's not as good as what yours will look like. But here's one on the x-axis. We're going to determine the limit as x approaches 1. Now, x can approach 1 from two directions. Now, you can approach 1 along the x-axis from the left-hand direction, or x can approach 1 from the right-hand direction. So you can go two ways towards 1. So I said we can't use 1, so what we're going to do is to determine our limit. Okay, we're going to take some numbers that are real close to 1. Now, those numbers we can use, and we're going to use those numbers to determine the limit. But we can't use 1 itself. So as you indicate this, as you just say this, this is the limit of the limit of f of x as x approaches 1. So that is, we never actually get to 1. 1's not in the domain, we can't use it, but we can get real close. So the limit as x approaches 1, what would that limit be? So let's start off, let's design this little chart, sort of like this here. Now, so once again, x equal 1 we said is not in the domain of f of x. When you substitute it in, you get 0 over 0. So we're going to calculate values of f of x that are close to 1. So here we go, here's our graph again. Now here's my chart. So you can see as the chart comes up now, on our graph, I'm going to put a little hole here, right where the point 1, 3 would be, right? So there's basically a hole in our graph, okay? So once again, the graph doesn't exist at x equal 1. So here's our chart. So here we go. Now, so go ahead and fix your chart up sort of like what we have here. And right in the middle here, I'm going to put 1. And I'm going to leave 3 spaces on the right, 3 spaces on the left. And I said, since we can't use 1 by substituting 1 in our function, we're going to get some numbers that are really close to 1. So let's see, close to 1, how about 0.99? That's pretty close to 1. 0.999, 0.99, and 0.9. So those are all fairly close to 1. Those are all just to the left of 1. Now we're going to pick out some numbers that are to the right of 1. So it's going to be bigger than 1. So 1.001. That would be very close to 1, 1.01, and 1.1. Right. And now, since we can't substitute 1 into our function for x, 1's not in the domain, let's take each of these and we're going to substitute them into our function for x. Now, so here's how this is going to go. I'm going to do the first one here. Now you can kind of follow, I want you to follow me on your graphing calculator. So what I want you to do, take the 0.9, substitute 0.9 into your function for x. So instead of x cubed minus 1, you're going to have 0.9 cubed minus 1. I put that in parentheses, divided by the quantity 0.9 minus 1 on the bottom of your calculator. So get a division, and when you hit enter, your calculator should automatically give you your value. So let's see what we get. Now when I did it, I got 2.710 approximately. So this is rounded off. I did the same thing with 0.99. So substituting 0.99 into our function for x here gave me 2.970. And now let's try through the 0.999. Right? So let's try this one. This is very close to 1, so we're getting very close. Right? Substituting this in for x, it gives us 2.997. Right? So you can see now from the left-hand direction, as x approaches 1 from the left, y approaches 3. So it goes 2.7, 2.97, 2.997. So y is approaching 3. Now let's try these numbers over here. 1.001, substituting this in, gives us 3.003. Okay, let's try the 1.01. Substituting that in, this is what I got when I did it. I got 3.030, all right? And then the 1.1 gives us 3.310. Now, as you look at your data from the right, as x gets closer and closer to 1, the y value goes from 3.3, 3.03, 3.003. So y is getting closer to 3. So as x approaches 1 from the right, y approaches 3. As x approaches 1 from the left, y approaches 3. So we can say the limit as x approaches 1 from the left or the right, we get the same number, is 3. So let's say as x approaches, f of x approaches 3, therefore the limit as x approaches 1 of this particular function is 3. Even though there's a hole in my graph. Now the hole doesn't matter because remember, we never actually get to 1. X only approaches 1 from the left and the right. So we actually never get to the 1. We get real close from the left, real close from the right, and then from there that'll tell us what the limit should be. Right? So even though there's a hole, we never actually get to the hole. Now let's see, let's bring up our next function. Now the next function, so you can go ahead and clear this one out of your calculator. Now this is example 2. So we're going to numerically estimate the limits. The limit as x approaches 0 this time of this particular function. Now we have x divided by the quantity square root of x plus 1 minus 1. So I'm going to try this one right here. So once again, hit y equals, go ahead and type this into your function, because I want to ask you guys to do this one first. Okay, this one is guided practice. Right? So make sure you know how to put this in your graphic calculator, and let's see if you're getting the same thing that I get. All right, so here's your function. All right, and we're going to determine the limit as x approaches 0. Now, first thing I want you to notice that, first of all, you want to try 0 first. When we determine the limit, try the number first. We try direct substitution. Now, the only problem is when you substitute 0 in for x, you get 0 on top of the function. On the bottom, you end up with 1 minus 1, which is 0. Once again, you get 0 over 0, which indicates a whole. So 0 is not in the domain of this function, so we can't use the 0. So this one has a hole in it also. So what we're going to do, we're going to pick out some values that are close to 0. So I want to help you get started with your chart. Right, so once again, 0 is not in the domain, so we're going to calculate several points that are close to 0. Right, now here's your chart. All right. So go ahead and fix your chart up, so like what I have here. So we're going to have x and then f of x. So x on top, f of x on the bottom. So put 0 on the right there in the middle. And we're going to try several values. Now, as you see these values come up, I want to ask you to pause the tape and see if you can use your calculator to generate these same function values. And let's see if you get the same thing that I got. So this is a little guided practice. I want you to do it first. So here goes. So we're going to try these 4 points. So once again, go ahead and get these down. I want you to pause the video and let's see if you can take at each one of these one at a time, starting with the negative 0.01. Take this number, substitute it in for x. See what you get. Then the next one, substitute it in for x. So do all 4 numbers. And let's see if you can determine what the limit is by looking at these 4 values. The 2 coming from the left and the 2 coming from the right. Let's see if you can predict what the limit will be on this one. And after you get done, then we'll go ahead and I'll go ahead and bring my values up and you can kind of check yourself and see how you did. Okay, now we're back, so I'm assuming that you already have the answers. So here's what I got. Let's see if you get the same thing that I got. Taking the negative 0.01, substituting this in for x, I got 1.99950. Right? So this is what I got. Trying the next value. Now this is even closer to 0. Right? Taking the negative 0.0001, substituting this in for x gives me 1.999. You can see 1.9995. Very, very close to 2. So you can see now coming from the left, as x is closer and closer to 0, the y value is getting closer and closer to 2. Now let's see if we get the same number on the other side. Now, the first value here, 0.0001, substituting this in for x gives us 2.0. Well, you can see almost 2. So very, very close to 2. Not 2, but very close. Try the 0.01, substituting this one in, gives us 0.200491. So you can see as x gets closer to 0 from the right-hand direction, the y value approaches 2 from the right. Now this is important because you have to approach the same number for the limit to exist. If we get 2 different numbers, a different number from the left, a different number from the right, that would indicate there's no limit. So the limit has to be the same from the left-hand direction and the right-hand direction. Remember, this is the limit as x approaches 0. So remember, we never actually get to 0, so we get closer and closer to 0. Right, so we're going to say the limit as x approaches 0 for this particular function from the left-hand direction and from the right-hand direction is 2. Right, so the limit of this function is 2. Now let's take a quick look at the graph. So if you were to graph this function, this is what it would look like. Okay, here you go. Now the thing is, if you're using a TI-83, TI-84 graphic calculator, you don't want to see a hole. Now if you go to your table and you go to x equals 0, you see it'll be undefined, or there'll be an error there to indicate that 0 is not in the domain of that particular function. But you can look on your table and you can see that it's there's an error or it's undefined there. But if you look at your graph on the TI-83 will not indicate a hole. And let's see, once again, this is f is not defined at x equals 0, and this is what our graph will look like. All right. So as x approaches 0, say that f of x approaches 2. So as x approaches 0 from the left-hand direction, the y value approaches 2. And as X approaches 0 from the right-hand direction, Y approaches 2 also in the direction. So we say the limit as X approaches 0 for this particular function is 2. This is how you determine the limit using a chart or a table. Right? So that's an easy way to do it. And we'll stop here and we'll continue with our next video.